Hey guys, today we are going to review graphing. Yay, our favorite. We love graphing. Okay, so we need to review graphing before we can do the next part of our statistics unit. So it might feel like we're kind of like pausing, but it's okay. We graphed a long time ago, and there are some things that we need to remember about graphing. So let's go over some of the basics when it comes to graphing. So when it comes to graphing, we have 4 different slopes. So the slopes that we have are increasing, decreasing, or positive and negative. We have pictures that have, oh no, broken pencil. We have pictures with no slope or a slope of 0, and slopes that go straight up and down. And we call these guys undefined. Okay, so if you forgot, watch your slope tube video. Okay, now when we have slope, we are counting our rise. Remember, that's like if you have a step and you have to lift your foot up, and it's always rise over your run. So remember, rise is how much you move up and down, and run is how much you move left and right. So it's always rise over run every single time. I'll write it like this. It makes a little bit more sense. Okay, so the rise value is like your y value, and your run value is your x value, which is different because every single other time we write ordered pairs, we always put the x value first. This slope is just slightly bananas. It is the only time that y is on the top, or y would be first. Okay, so now we're going to find the slope of each line. So remember, to find the slope of each line, we're going to take our 2 dots and we are going to connect them using our triangle. And we're going to count our rise and our run. So we rise 1, 2 boxes, and we run, oops, wow, that was an aggressive one. Okay, hold on. We run 1, 2, 3 boxes. So our slope for number 1 is 2 over 3. Now you always have to make sure you check if it's a positive or a negative or an increasing or a decreasing slope. So remember, when you walk left to right like you read, left to right. If you go uphill, that's a positive slope. So this is a positive slope. If you go downhill, this slope is going to be negative. Okay, and we're going to count exactly what that is. Remember, when you have 2 dots, you are going to connect your 2 dots using a triangle. So basically, we're trying to go from point A to point B. Now, in order to move from point A to point B on your graph, you have to follow the grid lines. So these are kind of like streets. This is our map, and these are streets. Okay, if we go off of the grid lines, then we're going to hit somebody's house, and they're going to be mad. So we stay on the grid lines. Okay, and it doesn't matter if you go above this way or down this way. It doesn't matter. It's rise over run. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. This cannot reduce, so we keep it the same. And again, since it's decreasing, because when we move from left to right across our graph, we're going downhill, so we need a nice negative for this slope. That's what students always forget, the nice negative. Please do not forget your nice negative. Don't forget your sign. Whether it's a negative or a positive, please be careful. Okay, let's look at number 4. Now this guy right here has no slope. He does not go up or down at all. There's no tilty. And we can walk on this. Like, yay, he's so happy. He can walk on this line. So that means our slope is equal to 0. Now that is different from number 3. If I'm standing here in the bottom of this in my classroom, I cannot jump this high. First of all, I'm really short. And second of all, it just doesn't happen. Okay, so this cannot happen. I can't move this way. I could walk uphill. I could walk downhill. I could walk on a no-hill. I cannot walk from the ground to the ceiling instantly. I can't do that. So this slope is undefined. Now, slope is just one part of graphing our line, and we're going to talk about the other part of graphing our line. So if you remember, we talked about our y-intercept. So our y-intercept is where our line touches the y-axis. Now these up top graphs aren't the nicest. They're right here on a decimal. That's not great. We're going to find some graphs that are in just a second. So let's look at number 8. Okay, so I gave you the slope. I counted the boxes and I figured out the slope was this. I saw where my line crossed the y-axis, which is the y-intercept, at 2. So now we have to write the equation. So remember, our equation is in the form y equals mx plus b, where m is our slope and b is our y-intercept. Remember, the m is your slope and the b is your y-intercept, and all you're doing is taking out this m and b and replacing it with what your values are. So to write the equation of this line, you always start with y equals, and then it's mx, so my m is negative 2/3. Always put your x next to your slope, and then you need to add your b at the end. It's the same thing on number 10. Y equals m, our slope is 0. Always put the x next to your slope, and then we're going to add our negative 1, our y-intercept, our b at the end. Now this equation that we wrote kind of looks a little funny. So if we have no x's or 0 x's, we don't have an x, so we don't need him there. Also, we never really write plus minus, it's usually just -1. So if we don't have any x's and we don't need this plus, really we have y equals -1. Now, this graph is like number 4, if I were to graph it, remember? So you go on the y-axis to where y is -1, and then it's straight across, because at every ordered pair on this line, my y is always equal to -1. So that's why this line is y equals -1. Okay, let's go back. Number 12. So our slope is our m. So we have y equals, our slope goes next. We always put our x value next to our slope. Then we add our y-intercept, our b, which is 3. And this is the equation of the line. That one's pretty simple. Okay, what else we got? Oh, now we're going to write the slope-intercept given the line. So I have this line. We need our slope, we need our intercept, and we're going to write the slope-intercept formula. Now remember, if it's tilty, it's going to have 2 letters. So tilty, T-I-L-T-Y, equals 2 letters. So that means like, like y equals 5x plus 3. 2 letters makes it tilty, okay? So this one would tilt this way because my slope is positive, and if I had like y equals -1/4 x plus 2, because my slope is negative, this is tilty this way, decreasing, okay? Now the non-tilty ones just have 1 letter. So like this guy is gonna have 1 letter, and this guy is going to have 1 letter. And the letter that it has is whatever axis it crosses. So on number 20, it crosses the y-axis at 1. So the equation of this line is y equals 1. Now you can go through all the steps if you would like to. My slope, well, it doesn't tilty. There's no slope to it. So 0. And my y-intercept, my b value, is where my line crosses the y-axis, and it crosses right here at 1. So if I wanted to, I could plug it back into my equation, y equals mx plus b, where my m is 0 and my b is 1. Now we just did this example on the other side. I don't need 0x, so y just equals 1, which is what we said at the beginning. Okay, so you don't have to go through all of these steps if you don't want to. If they help you, then go for it. Okay, back up to 14. It seems like I'm really jumpy, but it's not. It's okay. Okay, now, on these graphs, the thing that's different from the first ones and these ones is these do not have dots, so you're going to have to put the dots on. Remember, the dots go where the line touches the corner of a box. So here, that is not the corner of a box, so I cannot put a dot there. This is not the corner of a box. This is not the corner of a box. There is 1 corner of a box right there, so we put a dot there. This is not the corner of a box. This is not the corner of a box. This is not the corner of a box. Oh, we have another one. And this is not the corner of a box. This is not the corner of a box. This is not the corner of a box. Oh, we got another one. And probably here too at the very beginning. Now remember, we just need 2 dots in order to figure out the slope. We got lots of dots, and it's totally fine as long as you reduce your fraction. So I'm going to count my rise and my run. I'm just picking the middle 2, because why not? 1, 2, 3. So I have a rise of 3 and a run of 2. And since I go uphill as I move from left to right, it's a positive slope. Now my b value is where my line crosses the y-axis. Now they cross right here at positive 1, so that is what my b is equal to. When I write my equation, it's y equals m. We always put the x next to the m so we know it's the slope. So mx and then plus b, and my b value is 1. And remember, if it's a minus, you just put minus, you don't need a plus minus. Okay, number 16. Again, we need to put dots on our line. So remember, it's where the line crosses the corner of a box. So it looks like it crosses here, and then that's not a corner, not a corner, not a corner, corner, not a corner, not a corner, not a corner, corner. Okay, I've got enough. Okay, so now I'm going to figure out my rise and my run so that I can write my slope. So my slope, my rise is 1, 2, 3, 4, and my run is 1. Now, as I move left to right across my picture, I'm going downhill. Downhill is a nice negative slope, so please do not forget your negatives if you need one. My b value is where my line touches the y-axis because that is the y-intercept. It touches all the way up here at positive 5, so that's what I write down. Okay, now we put everything together, we write our equation, y equals, then I write my slope, negative 4 over 1. I always put an x next to my slope, and then it's plus 5. Now, you do not need this one underneath if you do not want it, so you could rewrite this as y equals negative 4x plus 5, and that would be perfect as well. Okay, let's look at number 18. This guy. Okay, we need to put dots on my corner of boxes. As I'm looking at this line, it looks like this line goes through every single corner of a box. So I can put dots on every single corner if I wanted to. Or since I know they're on every single corner, I'm not going to bother with it, and I'm just going to connect 2 of my corners. This has a rise of 1 and a run of 1, so my slope is 1 over 1, which is the same thing as 1 if I reduce. And you must reduce, so do it. If you decided to connect some dots that were further away, it'd be totally fine, and I will show you how. Okay, so we're going to count our rise. 1, 2, 3, 4, and 5. And a run of 1, 2, 3, 4, and 5. So my slope would be 5 over 5, which also reduces to 1 over 1, which is 1. My y-intercept, my b value, is where my line crosses the y-axis. They cross down here at negative 2. So now we're going to write our equation. Y equals, my slope is 1. Always put your x next to your slope. You have to have it there. And then plus negative 2. Now, a few things that we can change about this. First of all, we do not need a 1 here, so we are just going to write y equals x. It's a positive slope because we're going uphill, so we're going to keep that the same. I forgot to check earlier. And then I don't need a plus minus. It's really just a minus 2. So this is the equation of this line. Last but not least, we are going to look at number 22. Okay, so this line, again, we put dots. Where my line crosses a corner of a box, not a corner, corner, not a corner, corner, not a corner, corner, not a corner, corner. Okay, that's enough. Then I'm going to connect my dots using a triangle. Now, you don't have to skip a dot if you don't want to. I did. Okay, my slope. When I go from left to right across my graph, my slope is decreasing, so I need a negative. My rise is 1, 2, 3, 4, and my run is 2. Remember, you have to reduce if you can reduce, and I can reduce. So negative 2 goes into 4 twice, and 2 goes into 2 once. Well, you can keep going. We don't need this cute little 1 underneath. So my slope is negative 2. That is my slope. Okay, my y-intercept is where my line touches the y-axis, and they touch right here at 0. So now we can write our equation. Y equals, put your slope, always put an x next to your slope, and then we're going to add on our b value. Now, when we are adding on 0, we're not really changing it. We don't need this. So it is y equals negative 2x. That is the equation of this line. Okay. Now we are going to graph the line given the equation. So remember, the slope is in front of your x and your y-intercept is at the end. When you're graphing, you have to go backwards and you always begin with your B, and then you move with your M. So we're going to begin at -3 on the y-axis. So we go to the y-axis because it is the y-intercept, so it is where the line crosses the y-axis. Now we have to think about how we're moving. The first thing I always ask myself is, what is the sign? If it's positive, my line looks like this. If it is negative, my line looks like this. It's really good to think about what your graph is going to look like before you graph it. My line needs to be decreasing because it's negative. Now remember, you have a rise, so your slope, or your M, is rise over run. You have to move that way. So from where you begin, and you can only move from one dot to the next spot, we are going to move up 2. Now we have to think about what our graph looks like, so there's just kind of a placeholder. Okay, if I move to the right 3 over here, and I connect these 2 lines, that's what my graph looks like. But remember, my graph is negative and it needs to look like the pen. So I need to go the other way. I need to go up 2 and to the left 3. And up 2 and to the left 3. Then we can go back down to the beginning and go opposite. Down 2 and to the right 3. Down, oh, that one goes off the page. Okay, and then we connect our dots using a nice straight line with arrows at the ends. You need to make sure that your line goes all the way off your grid. This is not a dot to dot. We are not connecting the dots, but we kind of are. So here's the thing. Students, when they see dots on graphs like this, if this is what it looked like, hold on. This is what I see. Sometimes I see students do this. Okay, that reminds me of like a dot to dot, like 1, 2, 3, 4, 5. Okay, that is not what we're doing. We're graphing a line with the same slope, which is what this is as well. So you need a nice long line with arrows at the end, and it should go all the way off your graph. It should not go from one dot to the next dot. It needs to be a long line with arrows at the ends. So let's do another one. Number 26. Okay, so we always begin with our B value, and this negative is part of it. That's the whole thing, -4. Okay, we always begin on our y-axis, so this is our B. That's where we begin. And we're going to find where y is -4, which is here. So we put a dot there. Okay, now we are going to move. And we are going to move this, -4. Now remember, slopes are fractions. So if I have a -4 slope, I really have a -4 over 1. Remember, if it's negative, then that means I am decreasing. Well, I can't really go down 4 on this graph, which is fine. We're just going to go up from where we begin at -4. We're going to go up 1, 2, 3, 4 spaces. And since my run is 1, I'm going to go to the left 1, and that will make a decreasing slope. Again, up 1, 2, 3, 4, and to the left 1. I cannot go up anymore, nor can I go down anymore, so I make a nice long line with arrows at the ends. Number 28. Okay, so I don't have a B. Where did he go? If I don't have anything, then I have nothing. So we start at 0. That's where we begin. My slope, well, what number is in front of x? It's a -1, and not just a -1, but a -1 over 1. So it's decreasing and it's 1 over 1. So from my beginning, I go up 1 and to the left 1 because that makes a decreasing slope. I continue the pattern of going up 1 and to the left 1 all the way across my grid. I go back to the beginning and I do the opposite, down 1 and to the right 1. Because we're making straight lines, we're not making any zigzaggy shapes, so they should go opposite directions. When you get all of those dots graphed, it's a nice long line with arrows at the ends. There's more. Yuppers, keep going. Okay, let's look at number 32. When we graph this line, this guy is different. He has an X. So remember, one letter equals not tilty. So we go find him. Where is X equal to 3? Well, this is the x-axis, and he is equal to 3 here. Now, let's compare. I'm going to compare this ordered pair and this ordered pair. So this ordered pair that we just drew, this guy right here, has an ordered pair of 3, 0. Notice that the x value is 3, which is what we said. X was 3. It doesn't matter about this guy. Who cares? Okay, so let's write down this ordered pair. This ordered pair is to the right 5 and up and down 0. Does he have a 3 at all? No, he doesn't. So I cannot draw my line this way. I can't connect him. He has no 3. So let's look at this ordered pair. This ordered pair is 3, 3. Well, that was a bad example. Okay, this ordered pair, this is a better example. 3, 2. Let's do this ordered pair right there. That ordered pair is 3, negative 2. About this ordered pair. This ordered pair is 3, negative 5. What do you notice about all of these ordered pairs? They all have 3 as an x value, every single one of them. Our equation says where x is negative or is 3. So where is x 3? Well, x is 3 on this whole line. Well, that's got to be true with the y's, right? So if x is 3 on this whole line, well, where is y equal to negative 3? Well, let's go to the y-axis. Y has a negative 3 here. Well, what's this ordered pair here? This ordered pair is 4, negative 3. Well, what would be this ordered pair? This ordered pair is negative 6, negative 3. And what is this ordered pair? Oh, he is 0, negative 3. Where are my y's equal to negative 3? All on this line right there. Okay? And then last but not least, we're going to talk about this guy. Where is y equal to 0? Okay? So we're going to put a dot here. So let's look at this ordered pair. Well, this one is 0, 0. What about this guy right here? This guy is 2, 0. Oof, what about this guy? He's negative 4, 0. Let's look up here. What's this guy? This guy is at 0, 3. Ooh, what about this guy right here? He is at 0, negative 4. So remember, your ordered pair is x then y. So where is y equal to 0? Well, he's equal to 0 here for this 0. And he's equal to 0 here for this 0. So this is where y is equal to 0. So y equals always a horizontal line. X equals, this guy is always a vertical line. So this is no slope, and this guy is undefined. The x is the weird one, so he's the one that you cannot walk for his slope. Okay, please let your teacher know if you have any questions. Have a great day. Bye!